Hello and welcome to today's webinar presented by Dlubal Software. Today I'll be working in our structural analysis and design software, RFEM. The topic for today's webinar is BIM integration and RFEM. My name is Amy Heilig. I'll be your moderator answering any questions you may have. I'm the CEO of the US office and also a technical support and sales engineer, and we are located in Philadelphia, Pennsylvania. My colleague Lucas Sunel will be your presenter today. He's a product and customer support engineer located in our Tiefenbach, Germany office. If the control panel does seem to get in your way when you logged into this GoToWebinar, feel free to show or hide that with the orange arrow up at the top. We always want to encourage everyone to ask questions throughout the presentation. You can do so within the same dialog box. If by chance we don't get to all your questions, I will certainly send you a follow-up email afterwards. So regarding the content for the next hour today, this is the final RFEM webinar of our three-part series. This is really geared towards new users within our program RFEM. Then we move to the more advanced features, and finally we're ending with BIM integration. Today, my colleague Lucas will show a couple of examples. The first example will highlight the direct interface between Autodesk Revit and RFEM. For the second example, he'll focus on the direct interface between Tekla structures in RFEM. Throughout these couple of examples, he'll show the bidirectional and round tripping options available between both programs, as well as tips for optimized data exchange. And finally, at the end, he'll highlight some other BIM import and export options available. So with that said, I will go ahead and turn it over to my colleague Lucas.
Thank you very much for the introduction, Amy. Hello also from my side. In the next 60 minutes, I want to show you the interface to Tekla and Revit. And I also want to give you a rough overview about the other interfaces that we have. Why do I mention Tekla and Revit separately from the others? Well, there is a major difference. And the difference is the following. Most of the other interfaces that we have are file-based interfaces. File-based interfaces are limited by the options the format offers. So if the file format has no option to exchange, for example, load cases or load data, there's no way we can change this. On the opposite, the direct interfaces, they are based on the APIs of both programs. So this allows us to define the exchange according to our expectations, of course with the limitations of the APIs. That also requires that both programs have to be installed on the same PC. So you need to have Tekla or Revit and RFEM on the same PC to use these interfaces. Before I show a live demonstration of the interfaces, I want to give you an overview about the possible workflows. The first workflow is maybe the most common one. You would start in Revit. So maybe the architect or the BIM manager created the model in Revit. And while he was defining the columns, the beams, the slabs, and so on, Revit allows you to automatically create the analytical model in the background. And this analytical model can be exported to RFEM, including loads and combination if you want so. In RFEM, you can continue, you can modify the structure, you can add supports, you can add member hinges, load, you can combine the load cases, and of course, you want to run the analysis and the design. If everything works out well, you can finish your design, you can create a protocol, and you're done. Of course, it can happen that some details have to be changed. The thickness of the slab, maybe the cross sections, materials, maybe you even have to add objects into RFEM. And these changes that you made in RFEM can be transferred back to Revit. So you can update the Revit model with the changes you made in RFEM. This is one big circle. You start in Revit, export to RFEM, and update the changes you made in RFEM back to Revit. The second workflow is pretty similar to the first one. The only difference is basically that we are not working with the full model. So we are not exporting the complete model. We are only exporting a submodel, maybe just one surface, or only the steel elements from the structure. And why would you do that? Maybe you're only responsible for the steel analysis or for the steel design of the structure. Or you simply like to work, or you like to design it level by level. Then you can update each level separately. The other functions are similar to the first scenario. And then there's the third workflow, and that's working the other way around. So here you would start in RFEM or RSTARP. Maybe you're the structural engineer and you made a preliminary design of that structure in RFEM. And now you want to make a few drawings in Revit. You want to determine the masses. So you can export the RFEM model into Revit, into a completely empty Revit file. So this is also possible. In Revit, you can, again, create these drawings and make whatever you do in Revit. And even if you make some changes there, you can update the RFEM model based on the changes you made in Revit. So again, you have the full cycle, but this time you started with RFEM and not with Revit. These workflows, I mention here usually Revit in my in this document in the PowerPoint. They are, however, applicable to Tekla as well. So the first and the second workflow are more or less identical with Tekla. Only the third workflow, where we start in RFEM, export to Revit, we do not have that option to update the RFEM model in Tekla. So whenever I export from Tekla to RFEM, I will create a new file. Only Revit offers me the option to update my RFEM file. With that being said, I would say we can go and check out the interfaces directly. I want to start with Revit. So what I will do is I will open Revit and I will open RFEM. In the background, RFEM is already opened, but it's empty. There's not a single file open. In Revit, I already have a structure, and that structure is based on the example Amy used in the previous two webinars of that series. Let's have a quick look what we have here. We have a mixed structure made of concrete and steel. We have some concrete columns with a 12 by 12 rectangular section. We have some pile foundation, some isolated foundations. We have two slabs with openings or with one opening, and we have some downstand beams here. Additional to that, we have a steel truss member or steel truss beam, where the upper girder is made of a W8 by 28 section. And just as a side information, the beam or the upper girder is one member that's running through. There is no division in the vertical or diagonal nodes. So when I was explaining these workflows, I was mentioning the analytical model. The thing what we see here right now is the physical model in Revit. It's the physical representation. Yeah? Every column, every slab is a 3D solid. We are interested in the analytical model, and that will be created automatically in the background when you model a structure in Revit. You only have to use the structure tab when you model something. And when you're using a beam, a wall, column, or floor, any of these items, there is an option defined in the background to enable the analytical model. So whenever I create a new wall or a new beam, the analytical model will be created automatically at the same point, at the same time. I was using these options, so I got my analytical model in the background already, and I can display it. I can display the analytical model, and I can change the graphic display maybe to a wireframe model. And now you can clearly see the analytical lines of the columns and the analytical floor. Revit offers me options to modify the analytical model. If you click on any element, for example, these verticals here, these small columns, you have now an option to change the properties of the physical or of the structural column. And if you click here, you can also access the analytical settings of the column. In these analytical settings, you can, for example, already define a hinge at the end or at the beginning of the beam. You can change the alignment, the analytical alignment here. Or you have even some advanced settings that I've activated in that file already. You can, for example, assign the member type truss to that beam or the member type tension. What else do we have? We have the analytical lines of the downstand beams here. And the analytical line, I tried to make it visible somehow. They are placed directly in the plane of the analytical floor. This is quite important because otherwise they will not be connected in RFEM afterwards. So the analytical line of a beam and a slab have to be in the same plane if you want them to act together afterwards, which is the case here. So the analytical model has been created in the background, and there's even a specific view for that. So in my 3D view, 3D views, I have an analytical model that I can display, and it will look like this. Now you can see only the analytical lines and so on. We also see here that there are some loads. So Revit allows me to create load cases. I have 3 of them in my structure here: a dead load case, live load, and wind loads. And I also have a few loads assigned to these load cases. Now, this is what I want to export, or what I can export to RFEM, the analytical model. And I can do it the following way. I only have to go to the Dlubal tab here and press the Export Model button. So we have a part for RFEM here, we have a part for RStop, and some, well, general settings. If I click on Export, I have different options. The first option is the set direction of my, or the direction of my set axis in RFEM. Should it show upwards or downwards? I have an option to create a new structure in RFEM, clear. I have an option to override an existing structure in RFEM, which is also clear, I would say. And I have an option to update an existing structure. Maybe you can imagine following. You export the structure we have to RFEM. You modify that structure in RFEM. You add some loads, you add some supports. You work in RFEM, basically. And at some point, you get an updated Revit file from the architect or whoever. And that file includes additional openings, some cross sections have been changed, whatsoever. So you have 2 options now. You can either create, again, a new structure from that updated Revit model, but then you will lose all the things you've already done in RFEM. So what you can do in this case is you can update your existing RFEM structure with the changes that have been done in Revit. This is what this option is good for. And then there's the 4th option, and this is the export to a file. So you can export the analytical model in Revit into an RFEM5 file. In that moment, I want to mention again that we are using a direct interface between Revit and RFEM. That means we have to have both programs installed on the same PC. And the first three options imply that you have a license of both programs on that PC. That's not always the case. It could definitely be that the architect only has a Revit license and no RFEM. But if he still, but he still can provide that analytical model to the structural department by exporting it into a file. This export into a file also requires RFEM to be installed, which is quite easy. You can tell the architect or whoever creates the Revit model that he can go to our website, he can go to download 90-day trial version, and press the download link button here. You only have to enter your name and your address, but there's definitely no costs. Even after the 90 days, there will be no costs at all. So when the person who only has a Revit license installs our software, he will get this Dlubal plugin in Revit. And after that, he can export his analytical model into a file. He doesn't even have to open RFEM at this point. He only needs to install it. That's all he needs to do. So these are the main functions of the export. There are further settings that control which objects should be transferred to RFEM. You remember maybe the second workflow that I showed, where you export only submodels or partial models. This is the option which allows you to do so. So you can simply select a few objects here in Revit. You could, for example, select only the roof and a few beams, call up the export dialog again, and say you only want to export the selected objects. Then only these objects will be exported to RFEM. On the right side, we have additional options which control the export, and I want to explain two of them right now. The first one is the member eccentricities that we can export, and the second one is the function to connect lines and members. I'm not sure if I showed it, so because I forgot if I showed you or not. In that 3D model, I have this truss member, and the upper girder of the truss is one member. Yeah, I think I showed you. It's not divided in any of these nodes. So this option, connect lines and members, controls what's happening when you export that structure, that type of structure, for example, to RFEM. RFEM is able to deal with one long member or with the divided member. It's no big deal for RFEM. So for RFEM, it's no big deal to play with this option. For RSTUB, however, requires beams to be divided in the nodes where another beam is connecting to or intersecting. So if you are working with RSTUB, you most likely have to use this option. The other option regarding the member eccentricities, I think I can easily show you. So let me do following. I will export now only the roof, including, let's say, the members in that area. I call up again the export function. I create a new structure in RFEM only with my selected objects, and I do not want to apply the member eccentricities. If I export this, you will get following. You will get only the objects we selected. So far, so good. And I get my my downstand beams actually inside the surface of RFEM. In general, this is okay because you need to have both in the same plane so that they act together, that the stiffness is acting together. But of course, you want to consider the correct stiffness by setting them eccentric in RFEM. You can do it in RFEM quite easily. I will show that afterwards. Or you simply do following. You can call up the export options again. Maybe you want to override the existing structure now, and you can apply the member eccentricities. And now following will happen. Let's have a look now at the structure. You can see they are placed now below the surface, below the slab. The gap is just the thickness of the slab, which we do not display right now. I can easily change that. So if I display the thickness of the slab as well, we can see it's located on the right position right now. And this eccentricity, which we assigned here during the export, these 15 inches, they are based on the distance of the analytical line in Revit to the center of gravity of the beam. So this is the distance we used here. So regarding the other export options, in general, I want to export my complete structure. So I'm not using these selected parts here. I want to use the member eccentricities. And I also want to export the loads and load cases that I have in Revit. And additional to that, I can also convert my isolated foundations or my wall foundations, if I would have some, into nodal supports or surfaces with an elastic foundation. I decide to use nodal support here. So these isolated foundations will be converted into nodal supports afterwards. That's all I have to do right now. Let me quickly close this file here and run the export. All right, that's the export. We can check now the complete model in RFEM. In general, it looks quite promising. We have the columns, we have the slabs and all the beams. The column is a 12 by 12 rectangle column, so that's the right cross section. And we also got the right materials. And how do I know that? Well, if you open such a material, so if you open the library of that material by a double click, and the material will be displayed with the correct filters, you can be pretty sure that the correct material will be used. So the material which includes the additional properties about the yield strengths and all these things. How can you make sure that you get the correct materials? You can imagine in Revit, you can have a concrete which is called cast in place concrete. So that's the full name of the material in Revit. And when you import such a material into RFEM, we wouldn't know what to do with that, because our library has different names and yeah, what should we do? Well, in such situations, you can use the conversion tables. You can access the conversion tables not from Revit. It's nothing you can control from that interface here. You actually have to go to RFEM for that. Click on File, Import or Export, it doesn't matter. And in the detail settings, you can access the conversion file for materials and for cross sections. And that is set up quite easily in a very easy way. There are two columns. On the left, you enter the name of the material in Revit or Tekla or whatever software you use. And on the right-hand side, you enter the name of the Dlubal material. And whenever you export or import something, we will check these tables and look for matches. And I've done that in advance to the webinar, so that's why everything works out well here. Okay, what else do we have? We got the nodal supports, which have been converted from these isolated foundations. I only had the option to convert it into a hinged support. I do, however, want to have a fixed support, so I create a support of the type fixed and assign it to all these nodes. I have my downstand beams located in the right position. That's fine. I have the upper girder of my steel truss beam is a W8 by 28 section, and it's also one big member. Yeah. So I did not split it up into single segments here. Apart from this, I also have the loads and load cases, so these are the 3 load cases that I defined in Revit, and I can also display the loads. So they all have been imported from Revit. What would the next steps be? Well, first of all, I want to double check if I can calculate that structure or if I have to modify it somehow. So I just run the calculation of a single load case to see if I will get some instabilities because something is not connected, or if I get results, then this is a really good sign. You can continue with your work. The next steps would be the combination of my load cases according to the ASC7 code. And afterwards, of course, the design and the analysis. So we have modules that you can use to check the stability of steel beams or the stresses. You can calculate the required reinforcements in columns, in these downstand beams, in the slabs, and so on. But these are all things that I want to skip today. Amy has some really nice webinars where she explains all these options. I cannot add anything to this today. So what we will do is following. We will imagine what could happen. What could happen after the design? It could be that we have to change the thickness of a slab. Yeah? Maybe the thickness is not enough because of the opening, whatever reason, so we change it to 14 inches. Another change could be that we have some buckling issues, stability issues in the upper girder of the truss. So we can change the section here from a W8 by 28 into W8 by 31. So slightly wider section. For the roof, for some reasons, we are not allowed to change the thickness, but we also have issues here. So what we do in this case, we will add additional downstand beams. I create a new beam in RFEM. I connect it maybe here in that area. I can assign the same eccentricity that I used for the other ones. And after that, I can copy the beam to the other side using drag and drop. So I made a few changes here. I can recalculate my structure. Should be relatively quickly. And I can display my results now. I can display the internal forces in my surfaces. I can also display internal forces in beams, for example, the axial forces in my columns and so on. And to show you a wider range of possibilities, I want to do a quick design of the required reinforcements of the roof. I will not talk about the details here. I will just use the concrete surface module to calculate the required reinforcements in the roof slab. I'm using just a load case here. Again, I don't care about the design today. So I will get the required reinforcements for my roof slab, and I can display it, of course, graphically as well. So I got now all the results that I want to have. I have modified my structure, and the next step would be to update my Revit model with the changes I've made and also export some results. How can I do it? It's quite simple. I go back to Revit. Is that Revit? Yeah, I go back to Revit and I press the import function now. Again, I have some details regarding the import. I can update my existing structure. And if I'm using the default update, I can remove absent objects or not. So if I would have to remove the column in RFEM, I can also remove it here by selecting that option. If not, it will remain. Apart from that, I will change with this update the thickness. I can change the cross sections, I will add new beams here and so on. And I can also update my loads if I would have any changes. And additional to that, I can also import results. For example, for the members, I could import the axial forces that I've just displayed beforehand. And for surfaces, I can also import, for example, the required reinforcements that I calculated in the concrete module. I can also select the sources for the results. Maybe you don't want to have all the results from all these load cases or combinations. You can select them here. This is the general or the basic update function. There is a very conservative update as well, and this is the lowest option on the right-hand side here. Update only material thicknesses and sections. If you check that or if you activate that option, then all the other possibilities will be grayed out or removed. So again, this is a very conservative update. You only change the parameters of these objects. So the cross section can be changed, the thickness can be changed, and the material. But you're not able to modify the structure. If you deactivate that option, you're actually able to modify the physical elements in Revit. So you would be able to change the size or the shape of the concrete slabs. In some, sometimes you want to be on the very safe side, so you would use that option. In my case today, I'm going to use the full capacity of that update. I run it now. And I can check what happened. So let me display a little bit differently. First of all, let me check if the thickness has been changed. So if I edit the type of this surface, you can clearly see here the default thickness has been changed from 12 inches to 14 inches. Apart from this, also this section should have been changed. Yes, we get here a W8x31 section now. So it has been updated. The beam is still going over the full length, so it's not divided in these nodes. I have my additional downstand beams here. Yeah, I haven't had them before. I added them in RFEM. And I also have some changes in the analytical model. So if I go back to my analytical view, I can see that we also created these rigid supports on the bottom of the columns. Not only this, not only the structure has been updated, I also exported my results, if you remember. So first of all, I want to get rid of the loads here in that view. So let me quickly deactivate them. And if you want to display the results, you have to go to the Analyze tab, and on the right-hand side, you find the Result Explorer. In the Result Explorer, you can switch between the results of your load cases. You can activate, for example, the axial forces that were the only ones that I imported. And if you apply these changes, you can see the axial forces on your columns and beams will be displayed, including the values. You can use that Result Explorer to switch between the load cases if you want. Or you can even switch to the results of the required reinforcements that we calculated. So Revit allows us, or the interface allows us, to export the content of our Revit structure to RFEM or RSTOP. We can design it there if it's set up correctly and nicely in Revit. We can make a few changes in our RFEM and update the Revit model based on the changes we made in RFEM. And we can also import results. So we have the full circle based on the first workflow that I showed you, or that I showed you in the beginning of that webinar. Now I want to show you also the third workflow in Revit. So this was the one where we actually start in RFEM. So I will create a new and empty project in Revit. There's nothing inside. There are only some predefined families. So a few W sections, a few rectangular sections, but not everything. And I will go to RFEM. So as I said, we can imagine the structural engineer made a preliminary design in RFEM. And now he wants to make a few drawings. He wants to determine the masses. And that's why he requires the structure or why he wants to export that structure to Revit, because in Revit you have these tools for that. So what he can do is he can go back to Revit here, to the Dlubal tab, import the structure from RFEM. It's the same dialog as we had before. I don't want to import the results now, but with these options, you can import the structure from RFEM into a completely new Revit file. And it can happen that you get a window which shows you cross sections that cannot be matched with Revit types. So that window shows you that there is a section in RFEM, a W8x31, that we have no specific Revit type for in that file. We can check which families have been preloaded here, and we see there are some sections, but not the W8x31. What we have to do in this case, we have to load these family types. This has nothing to do with the conversion tables that I showed before. The conversion tables only create the matches between the Revit type and the cross section or the material in RFEM. But if the Revit type is not loaded, then we cannot match it. So this is something which relates to your template that you're using. So you have to load that type. And Revit also divides between beams and columns. So you have to be a little bit careful which Revit type you're loading from the libraries. So I will go to C Program Data Autodesk Revit 220 libraries, into my Imperial library. And here I have structural columns where I would have theoretically the W section, but I also have structural framing where I again have the W section. And I have to be careful what type is mentioned here. If it's a beam and braces, then you have to use the structural framing folder. If it is mentioned that the column is this is actually a column, then you have to go to the structural columns. Okay, I'm selecting the section that I'm using here, or the family. I'm importing it here, and after that I can continue with the import. So import succeeded. We can have a look at the 3D model. I will change the display a little bit. Yeah, and I think it's clearly visible that the structure looks quite similar to what we had before in Revit. So the Revit user can use that file, and you can continue with creating drawings and masses, or determine the masses and so on. So this is the interface to Revit that I wanted to show today. I showed two workflows. The first one where we started in Revit, went to RFEM and back to Revit. And the third workflow where I started in RFEM and I exported my content into an empty Revit file. Now I will close Revit and continue with Tekla. And therefore I will also close the RFEM file and open Tekla. So you can already see that I'm using the same file, and I'm using the same file because I want to compare the interfaces a little bit. Of course, I could have used a completely different structure, but then the comparison is always a little bit tricky. So I'm not going to explain everything again. In general, I have here a similar structure in Tekla. One thing I want to mention here is that the upper girdle is going through, so it's one member again, it's not divided. Apart from that, Tekla also divides between the physical and the analytical model. So the content that I see here is, or what I see here is again the physical model. I can also create the analytical model in Tekla, quite easy. I can go to the Analysis and Design tab, and in the Analysis and Design models, I'm able to create one or even multiple analysis models and analytical models. I created one here, and in my analytical model, I wanted to have the complete model to be converted. So this is the option which controls what should be converted from a physical into an analytical model. If you don't want to work with the full model, if you want to work again based on these submodels, then you would simply create multiple analytical models here. And in each analytical model, you can select the parts and the loads that should be part of it. And then you can again export it, level by level if you want so. Okay, in the analytical model, we have, well, it looks quite similar to Revit. Yeah, we see the analytical lines of the columns and of the slabs. I also have options here to modify the analytical model. If you double click on these elements, you can change the type of the member. So you can say this is actually a truss member, a compression or a tension member, similar to what we have in Revit, with a few more options here even. We can also change the member end releases on that beam. We can modify the axis, the position of the analytical axis. Yeah, so we have a few options to tweak or to modify that analytical model. I have no foundations here in Revit. I define directly that on the bottom of my columns, I want to have a fixed support. That's also possible in Revit. So there's a small difference between the models. Yeah, but that's what I have here. I also have load cases in Revit, dead load, live load, wind, which I can export to RFEM. And that's what I want to do right now. I want to export that structure to RFEM, and this interface will be controlled in RFEM. So if you go to RFEM, you have an empty model. You have here an icon that is called direct import from Tekla, and also one that's called direct export to Tekla. I think it's clear what's happening here. I will call up that function. And Revit gives me an option to import the analytical model and even the physical model. So that option is not possible in Revit. I cannot import the physical model. It is, however, questionable if you want to import the physical model. I can show you what happens if you import the physical model. You will, of course, get, again, surfaces and columns and beams. So we will convert it automatically. But if you have a closer look, you can see that these elements are not connected, at least not in this example. And the reason can be following. Since we are importing the physical model and then converting these objects manually or automatically in the background, we will have a gap, for example, between the column and the slab, because the slab will be reduced into a 2D element, most likely in the center, and the column ends on the on the bottom of the slab. So there will be a missing distance, or the column will be too short to connect to the surface. And this is what's happening here. There's a gap. So you can use the structure, of course, but you would have to modify it. Because of that, and because I have the analytical model in Revit, I want to import it, of course. So I go back to my import settings, and I want to import now the analytical model. I can import my load cases, rigid links, and I also have an option to deal with the set axis in RFEM. I run the import now. And let me deactivate a few things here. So let's have a quick look at the structure. It looks much better than the physical import. Yeah, we can see that the columns and the slabs are connected. We can see that I have already rigid nodal supports on the bottom of my columns. I imported them directly from Revit. I also have the correct materials assigned. You can see in Revit, the concrete that I'm using here, the concrete with 4,000 PSI, is only the name of that in Tekla is just 4,000. So if I would have imported only the pure name without the conversion tables, I wouldn't have gotten any value. Yeah. So the conversion tables again help me to convert it correctly into a material from my library. And what else? Yeah, we also have these truss members that I defined in Tekla. So you can render that complete structure according to the type of the member. Then you get a small panel on the right-hand side. You can see that blue is a beam member, green is a truss member. So that was the option that I defined in Tekla and also Revit before. And the difference that I see here is following. My beams are placed in the center of the slab, so in the, yeah, and not eccentric. So the interface doesn't support the export of these eccentricities. It is, however, not a big deal. I can easily change that in RFEM. So I can click on the section that I used for all these beams. I double click on one of the beams and I switch the type to rib. And in the rib specific settings, I can say that the rib should be placed on the bottom of the surface. So it will automatically calculate the eccentricity. Even if I would change the thickness of the roof, the eccentricity will be updated. And I can also define settings regarding the integration with if I want to use a rib here. Okay, so we can see they're now placed below the slab. Another thing that I see is that my upper girder has been divided into several members. So that happens automatically during the export. I cannot change it, but in the same moment, the export will create a set of member, and that set of member contains all the members that have been created now. And this is an important functionality because when we export it back to Tekla, we can refer to the set of members instead of the single members. I will show that later on. So in general, the structure is okay, I would say. We also get a few load cases. For some reason, there will be created an additional load case. I will remove this one, and I will assign these the self weight into my dead load case, as I had it before when I was using Revit. We can again check if the structure can be calculated here. So I run the analysis. And I can see, okay, the structure can be calculated. In general, the the export of Tekla was really good. I get again my internal forces in my surfaces, also in my beams. So this is something which is very this is proofs that the import was okay. We do the same again what we did before. We will change the thickness and the cross sections and so on. So we skip the design again. So I will change the thickness of that surface again to 14 inches. I will change the cross section of the upper girder again to W8/31. And I will also create these additional members here. I will assign the same settings regarding the ribs. Should be placed on the plus Z side, so equally to the other downstand beams. And yes, that should be all. I will calculate the structure again. And I will also design calculate the required reinforcements in the roof. Only for the roof again. Okay, run the calculation. And we can display it again just to double check if it looks similar, which is the case, and also the results for the load case. So I have now the same structure as I had it before, and I want to export these changes that I made back to Tekla. Therefore, I can call up the direct export to Tekla structures here. And I have following options. I can override my existing model. I think it's clear. I could append it to the existing model, and I can update it. If I update that structure, I have additional options. And the first option here is following. You can create only one member from continuous type set of member. So remember, the members in the upper girder have been divided, but we also created this set of member which contains all these members. So now, because of that set of member, it will again export only a continuous long member instead of the single members. So this, fixes the issue with the division of the members. I'm also able to export the internal forces of my current view. So in my current view, I have the internal forces of my dead load case. So this is already, not as good as in Revit. We are only able to export, first of all, internal forces and not the required reinforcements. And I'm also only able to export the forces from one situation. Apart from that, I have some additional update options. I can update coordinates, the materials, the cross sections, the thicknesses of slabs, and I can add new objects or remove. So this is again quite similar to Revit. I can run the update now. And we will of course check the content of that in Tekla. I go back to Tekla. And we can check if the updates have been done. So I click on my slab. I can see it's 14 inches now instead of 12. I can also double check the cross section. Yep, W8/31. And also the additional downstand beams have been created. The color is different. It looks like they're steel, but actually it's also concrete. It's just the color which we can change here. Okay, now what about the results that I exported? How can I, make them visible? Tekla has here a few limitations, or let's say a different philosophy how to display these results. You can display the results if you click on a member, right-click, and you open the detailed informations of that member. And in this information box, you can see the internal forces at the end and the beginning. So 1 and 2 is end and beginning of the member. So here you can display the internal forces. So if you want to design a connection in Tekla, you can refer to these internal forces. This is how you can display the results in Tekla. The required reinforcements, for example, which we had in RFEM, there's no way you can display it here directly. Tekla or Trimble in general, however, offers a different tool to do so. And that tool is called Trimble Connect. So what you can do in this case is following. You could display in RFEM, for example, the required reinforcements in that slab, create a nice view, maybe enable a few values. And then you can make a picture. And you can save that somewhere, wherever you want. Okay, I saved it on my desktop. And you can do following. To link that information to Tekla, you can call up Trimble Connect. And in Tekla, you can export your structure to Trimble Connect. I did that in advance, to be honest. And you can also create an IFC file based on that structure, which you can link to Trimble Connect. And in that webinar project that I've created, I have here my IFC file that I also created from Tekla. I can navigate through that IFC file quite easily. And I can select, for example, the slab, the roof, and assign documents to it. I can assign the document from my desktop, required reinforcement roof, which already exists because I did it before as well. And I can select it here, and then it will be assigned to that slab. So, and what does it do? When you use Trimble Connect to select the data from different sources, you can display them. So if I select this slab, I can show related pictures, documents, whatsoever. For example, the required reinforcements. I did it already for a column down here. Here I designed the required reinforcement in the column, and I linked that graphic also to the IFC object of the column. So Trimble Connect is maybe the tool you would use if you want to document results from RFEM or whatever application together with the Tekla structure. So this was the interface regarding Tekla. I think in general you can say that both programs offer the same options. You have the same workflows. Of course, they are slightly different in Revit and Tekla, but the basic functions for the analytical model you can access in both programs. This is the information regarding the direct interfaces. And now I want to give you, in the last 5 minutes, a short overview about the other interfaces that we have, these file-based interfaces. So I can close Tekla and Revit right now. Actually, I can do this afterwards and give you a quick overview about the other interfaces. The other interfaces are included in RFEM. So if you go into RFEM, into File, you have the options to import and export. files. If you open the import, you see already all the formats you can use. Apart from these extra formats, all other ones come along with the RFEM license. So when you buy RFEM, you get all these interfaces for free. Only the extra formats have to be purchased. So what kind of interfaces do we have? I'm going to start with the left one here. Basically, they are more or less all connected. All are based on the DSTV format. So it's format for frameworks only. So if you have a pure framework, you can think about using these file formats for the exchange. We can export and import that. And it's, even though it's a little bit of an oldie, it's, you notice it's an oldie but in goldie. It contains so many information. It contains information about materials, about the sections, about the hinges, about eccentricities. You can exchange the different member types that we have, truss, tension, and so on. Nodal supports can be saved in these files, member elastic beddings, set of members, even loads and combinations and results. So this file format, even though it's a little bit old, is still very strong. So whenever you have an option, so if both programs that you're using enable you to export into the DSTV format, you should give it a try. We have additional formats, general formats for CAD programs. Of course, we have the DXF exchange, so we can import and export DXF files. We do, however, import only the simplest elements, so only lines and 3D, what is it called, 3D face elements. We cannot import blocks or anything like this. So if you created a block in AutoCAD, you have to explode it down to the lines and then we can import it or export it. We have an option to import and export the IFC files. Regarding IFC files, you need to know that there are different views. And the most common ones are the coordination view and the structure analysis view. We are able to import both views, structure analysis and coordination view. Regarding the export, we only can export the structural analysis view. Most common one is really like 95% is probably the coordination view. This is the view, like the sub language, if you want to call it this way. Most CAD programs use the coordination view. So when you export an IFC file from RFEM, when you export your content into an IFC file in RFEM, then you most likely cannot open this file in any other CAD program. But you can open the IFC file from other programs in RFEM. We have the ISM interface, or the interface to Bentley. This actually is again a direct interface. So when you want to create, import or export ISM files, you need to install the Bentley Structural Synchronizer. That's a tool you can download again on the Bentley page. Just Google Bentley Structural Synchronizer. You will end up on this page and you can download the synchronizer for free from the Bentley store. It doesn't cost anything. Yes. Then we also have the SDNF format. This is the format invented by Intergraph. So if you want to exchange data to Intergraph, this is most likely the one you want to use. The interfaces down here are maybe not so important. For the mechanical engineers that are watching, this is probably the interface you have to use. Mechanical engineers usually use programs such as CATIA, Inventor, SolidWorks, and they have the export into the STEP format, standard for exchange of product model data. When they export the content, into these formats, they will export the solids, so 3D objects. And we can import the boundary surface of these 3D objects. So this is what we can do with these extra formats. And this is actually an add-on module, which is called RFLink. So these are the file-based interfaces that we have. I hope I was able to give you a rough overview about the file-based and also the direct interfaces. And yeah, I can only ask you to try these interfaces, play with them to get a feeling, and hopefully, yeah, you can use them in an efficient way. That would be all from my side. So you can take back the control, Amy.
Perfect. Thanks, Lucas. As always, we know this is quite a bit of information, not just about BIM integration, but as on our software as well. So you can always visit our website at dlubal.com to find more information about RFEM, the add-on modules, and BIM integration. We also have our web shop available if you're interested in pricing. I always encourage everyone to follow us on our social media sites. For example, YouTube will have all these previously recorded webinars available. We also announce our newsletters, events and conferences, technical articles, frequently asked questions. These are all available on those social media sites. If you have any questions about today's presentation or anything else regarding our software, you can contact us in our Philadelphia office at info-us@dlubal.com. Our phone number here is 267-702-2815. We will have many more upcoming webinars. We try and do them about once a month. You can register on our website at dlubal.com under support and learning and webinars. As most of you know, I send out a reminder email about a week before the webinar will take place, so feel free to sign up through there as well. Many of you are wanting PDH certificates for today. These will automatically be emailed to all participants. So if you were here for the full presentation, which the full presentation is required by all the states that we are authorized to issue PDH, you will receive that PDH certificate automatically through email within the next day or shortly after this webinar. If there were any attendees that you watched with a colleague or you watched as a group and you yourself did not register for this webinar with your own email address and name, you will need to request a PDH at our email address shown here, info-us@dlubal.com. Again, if you yourself did not register with your own name and email address, please send us an email to request that PDH at info-us@dlubal.com. So as always, we want to thank everyone for attending today's presentation, and we hope to see you at the next webinar. Thank you.